Welcome to Secure Software Development. We'll get started the same way we start every class, by talking about computer arithmetic. Computer arithmetic, whatever you might think about it, right? It deals with numbers in a finite field. That is, there's only a finite number of different values that the computer can represent. Each number is basically a bag of bits, and it's a fixed size. For example, an int in C is typically 32 bits long, and so that can take on 2 to the 32 distinct values. Now, we can decide how we want to map those to numbers. If we wish, we could map them to characters or something else, but if we want to map them to numbers, clearly, we'd like to have the widest range possible. And that implies the encoding that we're used to. Doesn't have to. We've tried other approaches over the years and have sort of settled on the current way of understanding bits, but it didn't have to be the only one. So let's take a look at the code over on the right here, integers.c. So again, notice int types.h. You should really be using int types.h if you're not already. So here we have a little program, and we initialize the value to 4 billion. We print it out. Then we negate it, and we print out negative 4 billion. We multiply it by 10, and we print out 40 billion. We multiply it by 10 again and print out 400 billion. And finally, we add it to itself and print out the result, which should be 800 billion. Now, keep in mind, we're doing this in a 32-bit field. 32-bit integers, right? That's 2 squared times 2 to the 30th. So that's 4 times a billion. That's basically 4 billion. We're bumping up against the limit of what we can represent. So what's going to happen when we do some of these things? Also, when we negate it, what's going to happen? It's an unsigned number, right? We declare it to be a uint32, an unsigned 32-bit integer. So what's going to happen? Well, let's compile the code and run it and see. 4 billion prints that out just fine. Negative 4 billion? Okay. 294,267,296. Okay. Negative 40 billion? Well, clearly we took that other number multiplied by 10. But then for negative 400 billion, we get something else crazy. And when we double it, we actually get a smaller number. So all that is wild. So that's not great, I guess, but it's probably something that you've come to expect. That's the result of integer overflow. Integer overflow is a problem that plagues all computer languages. You just have to deal with it because, again, computer math takes place in a finite field. Let's try it in Rust. Right? Everybody likes Rust. So we'll do the same thing. We'll just basically transliterate that same code over into Rust. And you can see a few differences. We define value. We put a U32 on the end to indicate that it's an unsigned 32-bit value. And then we just do basically the same stuff. So let's compile it with the Rust compiler and see what we get. And the first thing we get is an error. It says, hey, what are you doing? You can't negate an unsigned value. Why are you trying to do that? Fine. But I can subtract one unsigned value from another, right? So what if I replace value gets negative value with value gets 0 minus value? When I do that, it compiles just fine. Okay, great. So we got through that hurdle. Let's try running it. When we run it, we print out 4 billion, and then it says thread main panicked and attempt to subtract with overflow. What? First of all, subtract with overflow? Would that be subtract with underflow? I'm not sure I follow that, but fine. Subtract with overflow. So, what do I do here? Well, I know one thing that can usually fix this kind of error where the compiler is trying to protect you against errors you've made. And that is optimization. So let's go ahead and compile it with optimization turned on. And when we do, great. Now we're back to getting the correct set of answers. We get exactly the same answers out of Rust that we got out of C. All we had to do was turn optimization on. And again, it plays all computer languages. So here's a program written in Steel Bank Common Lisp, because that's the Lisp compiler I have on my machine at the time I wrote the slide. Steel Bank Common Lisp is a variant of Lisp. If you're not familiar with Lisp, well, what's wrong with you? Go out and learn Lisp. It'll take you an hour maybe. And we do the same kind of thing here. You see, we set value to 4 billion. We print it out. We negate it. Multiply it by 10. Multiply it by 10 again. Add it to itself. So let's try that and see what we get. Oh. Okay. Well, we get the correct results. So what this means is that Lisp is not a programming language, and that's fine. Clearly, we can ignore it as a result. In reality, what's happening here is that Lisp has a notion not of 32-bit integers or 64-bit integers, but of just numbers. And numbers can be represented with a certain number of bits. If the number gets too large for that, Lisp goes ahead and expands that to a larger size of storage. If it goes beyond that, it may expand it to a big num, which basically gives it arbitrary numbers of bytes to store the number. And so you just have numbers until you run out of memory. And so that's interesting. It has some good properties, like it does this correctly. It also is a little slower to do it this way. But speed isn't necessarily the highest concern for Lisp. So let's talk about something a little different. Let's talk about fixed precision arithmetic. Some computer languages offer fixed point arithmetic. What this means is, instead of the decimal point floating around us, keeping track of an exponent, the decimal point is fixed at a specific position. That is, there is a fixed number of digits to the right of the decimal point. Like for currency work, you typically would have two, right? You'd have dollars and cents, or you have euros and cents, etc. Pesos and centavos, whatever you have. It's heavily used in the financial sector for that reason. And many cool and very popular computer languages directly support fixed point arithmetic, like PL1. The kids love PL1. And COBOL. Who doesn't love Ada? Curl 66. SQL. You all just love SQL, right? Yeah, okay, maybe not. The advantage of fixed point arithmetic is that it avoids conversion errors. You have a fixed number of digits to the right of the decimal, and we just make sure that works correctly. And in the world of finance, conversion errors can be bad. You start losing pennies here and there, it adds up pretty fast. The need for fixed precision can be gotten rid of if we use a language that supports decimal floating point values. And there are languages that support decimal floating point values, or for which there are libraries that support decimal floating point values. What do I mean by isn't like, and are they all decimal? No, they're not. C and Rust and others store them as binary floating point values. That is, there is a binary mantissa and a binary exponent. And they're represented in binary, as integers written in binary. What we're talking about here is writing those things, but writing them down in decimal, actually recording the decimal digits, possibly one per nibble, that make up the decimal digits of the number. And so we don't get the same kind of errors from this that we would get when we did, for example, the work with binary. We divide things. Sometimes they don't divide evenly, and you get little weird leftover stuff at the end of the number. No, we don't get that kind of a problem with this. Not if we expect to be working in base 10. Python and C# are examples of languages with decimal floating point. And you might look into the Kahan summation algorithm. It's not directly related to this, but I think this is a good place as any to shove it in there. There are errors that can arise when you do summations or do other repeated operations. And a way to deal with that is to keep track of the error and deal with it at the end. And that's effectively what the Kahan summation algorithm does. It's one of the many algorithms that you would look at if you're trying to really get the math correct. So let's talk about fixed point arithmetic. We don't need fancy types to do fixed point arithmetic. We have integers. If you give me integers and I can keep track of where the decimal is, I'm good, right? I mean, the number 3.4 is the same as 34. I just have to remember to put the decimal between the 3 and the 4 to remember where it goes, and I'm good. Can I do that? Of course I can do that. You learn to do that in grade school. So here's the little program where we get the cost of a Chromebook from Amazon, multiply it by 15, add the Tennessee sales tax, and then compute the total. And we do all this with integers. Okay? So let's take a look at that little program. So we go over here and we get int types.h. We get standard.io.h so we can read and write. And we define this little macro. This little macro is interesting. I define a macro called printx. I give it a format and a value. And it consists of a printf of the format concatenated with a $, and then %d dot %d/n. So this basically puts a $, and then one integer, a period, and another integer, and a new line. And what is that? Well, value divided by 100. That's an integer, so this is integer division, so it's truncation, right? 170 divided by 100 would be 1 because of truncation. We're not rounding, we're truncating. And 170 mod 100 would be 70. So I wind up with 1 and 70, and I would print 1.70. Wow, okay, so that's how that works. So then I come in here, and the Samsung Galaxy Chromebook costs, the time I looked this up, $698.78. So I'll convert that to an integer, 69878, just remembering that the decimal goes 2 places in. And I can use printx to print that out, and it'll print out 698.78 correctly formatted. We want about 15 of them. Well, multiplying a number by 15, that just works, right? Remember, when you multiply two numbers with decimals, you count the places to the right of the decimal, and that's how far over you move in the result. Well, 15 doesn't have any decimals in it. That's just the number of Chromebooks I'm buying. This has 2 places, so the result of this would still be a number with 2 places to the right of the decimal. So nothing to worry about there. So now subtotal is my total for 15 Chromebooks. And now we come to tax. What is the tax in Tennessee? Well, tax in Tennessee is 9.75% of the sale price. It's just what it is. So I take my subtotal, which has 2 places to the right of the decimal. I multiply it by 975. Okay. I add 5,000. Why do I add 5,000? We'll come back to that. And then I divide by 10,000. So what all is happening here? What all is going on in this little guy? Well, a bunch of stuff is happening. Subtotal has 2 positions to the right of the decimal. 9.75 would have 2. That would give me a total of 4. But it's 9.75%. And remember, percent is just a fancy way of moving the decimal to the left 2 more places. So really, I have 2 digits to the right of the decimal in the subtotal, and 4 to the right of the decimal here with the tax. The result will then have 6 to the right of the decimal. Wow, 6. Okay, I don't want 6. I want 2. So what I need to do is divide by 10,000, right? This will remove 4 of those positions of the 6, leaving me with just 2. Great. But it truncates, right? Division truncates. And I need to round. I really do need to round in this case. So what I do is I add 5,000. Now, why does this work? Right? So I've got my 6 positions. And so this adds 5,000 to the end. And so what it's going to do is it's going to increment that last position that I'm keeping if the result is 5 or greater. And then I divide, and I get the correct rounding, and I get back to a tax that just has 2 digits to the right of the decimal. Hope all that's pretty clear. I put it out, and now I compute the total. I take the subtotal, add the tax, right? I'm just adding 2 numbers with 2 positions to the right of the decimal. So that's what I get, and I put it out, and I'm done. Does this work? Yeah, it works. Works great. So that's the output that I get from it. Now, you'll notice I had to keep track of some stuff. I had to do rounding. I had to keep track of the number of digits when I multiplied and so forth. It would be great if there were a library that someone had built that would be sure and do all this correctly and not rely on my poor bookkeeping skills. And in fact, there are, and I've linked to one over here at libfixed. So why would you do this? Why would you? We have perfectly fine floating point numbers. Why go this way? Well, one reason is speed. Integers are just fast, are just super fast. And if I don't have to worry about a whole bunch of other stuff, it's going to be really fast to just do math this way. Precision. I avoid all those weird, pesky rounding errors and crust that you get when you do the work with these floating point numbers, right? I'm not going to get 60 point. I'm not going to get 0.6700000001. I'm always going to have exactly 2 positions to the right of the decimal, and that's great. And then, of course, the third benefit is speed, because speed's really important. Especially if you're doing financial calculations. If you're doing financial calculations and you're trying to shave milliseconds or microseconds or picoseconds off of your operations, integers might get you there. Remember, graphics cards do a lot of floating point math, but they can also do integer math and do it really fast. So let's think about stocks for a minute. Suppose you are the National Association of Securities Dealers Automated Quotations. That's what NASDAQ stands for. That's where the NASDAQ comes from. NASDAQ was created to trade these more highly volatile emerging stocks that the established New York Stock Exchange and others didn't want to trade or weren't able to trade. So NASDAQ is up there. You want to do some financial calculations. So you store the stock's per share price in a 32-bit integer. We've already agreed that 32-bit integers can hold a value up to 4 billion, roughly. A little more than 4 billion, but up to 4 billion. Wow. That's way more than the most expensive stock costs. It's a lot more than the most expensive stock ever costs. So we should be fine. It turns out when you're doing these kinds of calculations, you don't want 2 places to the right. You want 4. And so most of these use 4 places to the right of the decimal. Okay? Right? Tenths, hundredths, thousandths, 10,000ths. So there you go. If we allocate 4 places to the right of the decimal, we wind up with a maximum value we can hold in a 32-bit integer of 429,496 and about 73 cents. That's getting close to $500,000 for a single share of stock. That's clearly absurd. We're never going to reach that, or at least not for a long, long time. We should be fine. It should never be a problem. That's great. It's, one of the things that we know is that stocks only go up. They only ever go up in value. We can point to a dozen Reddit threads that tell you that stocks only ever go up. So since they only ever go up, eventually we will hit that $500,000 a share limit. But not for a long time. We got plenty of time to not worry about that. It turns out that in March of 2021, we hit it. And by we, I mean NASDAQ hit it. The price of Berkshire Hathaway exceeded $435,120 per share. Now, that's larger than the maximum we can hold in a 32-bit integer. And what happened? Well, you can see over on the right-hand side what happened. You see the stock price just like trickling along there, going up slightly, and then it hits that magical threshold, and it wraps around, and now you can buy it for peanuts. That's great. If you bought stock during that period, good on you. What they did was they suspended trading. They just basically stopped it. Said you can't trade the stock anymore until we figure this out. Other exchanges were okay, but the NASDAQ was not. The solution to fix this? 64-bit integers. Our work here is done. Fixed forever. And there you go. So integer overflow can lead to some funny business, but is it a security problem? Is there anything wrong with integer overflow that might affect security? Well, maybe. The code on the right comes from SSH prior to version 3.4. And if we take a look at this, I'm not going to go into details of all that it does, and we don't really need to. You can see what's happening. We have this thing called packet get int that returns something in resp, number of responses. If it's greater than 0, then we do an xmalloc. We basically do a malloc of the number of responses times the size of a char pointer. Character pointer is probably 8 bytes. So we take the number of responses and multiply by 8. And then we go into a loop. And for each one of the responses, we do a packet get string and store that string, it's a char star, in the response at that position. There you go. So we get a number of responses we're getting. We allocate space for all of them, and then we read all of them, and life's good. Never going to go wrong. Except, what if the packet we get, and remember we're getting this from outside, right? This is coming in from an external system or from the user. Someone else is setting that value. What if they send us a value that's like really, really, really high? It's so high that when we multiply it by 8, it overflows. Well, what happens? We allocate almost no space, right? We overflow, so instead of allocating some really big amount of space, we allocate a tiny amount of space. But then we still read in the total large number of responses into memory. That feels like it's probably a problem, and in fact, it's a big problem. They fixed this, and when they fixed this, they realized integer overflow is a serious problem. It's something we should go to the library, be very careful and deliberate about, and make sure that we don't allow integer overflows to occur anywhere else. And they fixed everything forever. And you don't have to take my word for it. You can Google open SSH integer overflow vulnerability, and you won't get a bunch of results. Some that are pretty recent. Of course not. The lesson here is sarcasm aside, the lesson is that security is hard. So yeah, integer overflow can affect security. For 17 years in Windows, there was a remote code execution vulnerability. I'm not going to tell you all about it. I will just point out that finally we have a vulnerability that gets a perfect 10 from the judges. This is a really, really big one. And it was there for 17 years. And we know people were exploiting it. It was reported in July of 2020, and it's since been fixed. Instead of telling you why this happened and how integer overflow relates to it, I'm going to point you to this article linked here, SIGRED, Resolving Your Way into Domain Admin, because it's so good. It's just such a good article. I don't think I have anything to add. You should read it. So, one thing that's an interesting follow-on to the saga of SIGRED is this. So, once a vulnerability is announced, people want to go and get exploit code. I want to go get exploit code, but I want to tinker with this and see what's really going on. The descriptions of the vulnerability, they might tell you some general stuff like it exploits a buffer overflow in this module. How? What does it do? Which buffer is overflowing? It exploits this integer overflow vulnerability. Which one? Where? What? Tell me more. If you really want to know what's going on, you need to go look at exploit code to see how it's actually done. And that's always fun to do. But it can be hard to find exploit code, to go and look around for it. So Andy Gill saw what was happening, and he said, hey, I've made an exploit. He created a fake exploit on GitHub, and he basically created a binary loaded with canary tokens to see who was running the script. So when the script runs, the canary tokens phone home and let him know the script ran. So it wasn't malware, really. It was just a little thing to say, who's grabbing my fake exploit and running it without checking to see what it is first? And a lot of people did, right? How many people blindly trust what they read on the internet? A lot. It started out as a troll, but quickly turned into a research project. And you can go and read about it at the link there at the bottom of the page. I just thought that was interesting. Interesting follow-on to that. So let's talk about ethics. So whether you realize it or not, you are learning some really powerful tools here in the computer science department at Tennessee Tech. It might not seem that way to you, but the modern world is a software-determined world. Your car has safety features that are enabled by software, like collision prevention, traction control. Your steering is very likely not directly linked to the torsion bars, but basically software controls that. We know software controls braking because of the Toyota braking issue. So basically when you're driving a car, you're offering some advice. The software is reading the sensors, finding out what's going on, and then deciding what should happen. Software lands airplanes. Software powers the Da Vinci surgical robot that performs surgery. The quality, the safety, the wealth of the modern world is largely determined, perhaps entirely determined, by software systems. And that puts a lot of weight on the people who develop these software systems. Okay? They affect people's lives. Software systems guide bail and sentencing decisions. They track your creditworthiness. Recently, there have been several stories about how people are using software to determine how much they can raise rent. How many people will they force out? How much, where's the sweet spot where they can make as much as they possibly can, admittedly forcing some people out. And this is all very serious. So ethics is the branch of practical philosophy that tries to pose and answer the question, what should we do? Not what can we do, but what should we do? And it concerns values, principles, beliefs, norms, and it implicates law, authority, and policy, because those, at least in theory, should derive from some set of ethics that guide them. Now, I'll mention here at the bottom of the slide, ethics and morality are often explicitly conflated, even by professional philosophers. So I've got several books on ethics, and in many of them, the authors will say, I'm just going to use the same term for both. Stop, don't bother me, leave me alone. But generally, morality concerns principles, while ethics concerns rules, right? So your professional society, the IEEE or the ACM, will issue ethical guidelines. These are rules that they expect you to follow. But you will have your personal morality, right? You'll have your set of principles that you believe you should follow. If you're interested in this distinction between morality and ethics, go read Election by Tom Perrotta or watch the film. I recommend you watch the film. The film's really good for further details. One of the first things in that film is the teacher asking Tracy Flick, what is the difference between ethics and morals? It's a fun film. It's very funny. What about public policy, right? Ethics is the branch of philosophy concerned with right and wrong behavior, and public policy is all the institutionalized elements about what society considers right and wrong. So certainly those two should have some kind of a connection, but it's weak at best. Ethics may or may not inform public policy, and ethical standards are very seldom turned into binding law. But they can be used in pursuit of enacting a law, or in defense of repealing a law, or in some other way within the courtroom, let's say. Public policy, right? That's concerned with laws, regulations, guidelines. What should we let people do? How do we want to see society structured? And public policy can be informed by ethics, but it really concerns a different scope of action than usually covered in ethical systems. And an interesting question is, does following the law guarantee ethical behavior, or does behaving ethically guarantee that you're following the law? And the answer is not really. And I point to Les Miserables for that. You've all read Les Mis, probably. And so you're familiar with Javert and his crisis of conscience. What? An honest servitor of the law could suddenly find himself caught between two crimes, the crime of allowing a man to escape and the crime of arresting him? He resolves the conflict by unaliving himself, but, there are probably better ways to deal with that kind of a conflict. One is to seriously examine your assumptions, which he does not seem to be willing to do. He can't let go of either thing. So, stealing a loaf of bread to feed your family may be illegal, but it may also be ethical. Ethics and law can diverge. Does equal treatment make something just or unjust, right? We ought to talk about equality under the law. Well, Anatole France, the Red Lily, we've all read Anatole France, I'm sure. And he says the law, in its majestic equality, forbids rich and poor alike to sleep under bridges, to beg in the streets, and to steal loaves of bread. And you can see where he's going with this, right? Equality doesn't guarantee an ethical basis for things either, right? We typically, when we want to talk about trying to make things, usually when people are talking about how society should be structured, they're not necessarily talking about equality, they're more talking about equity, which is a different concept. Okay. So that doesn't get us there. So what do we need to consider? Well, there's lots of things to consider. there's a potential to help or harm others through our actions. That should matter, right? If we're going to hurt somebody, well, that has more moral weight to it than if we're not going to hurt someone. Maybe I should take the action that hurts the fewest people or that helps the most. Maybe that's a guidepost. Does what I'm doing fit within a set of standards? Right? So I have professional standards. I have societal standards. I have the standards my parents and my church and my school impose on me. And as long as I fit within those standards, maybe that's where I should be. Free will. Moral acts are chosen by exercising one's free will as a consequence of a judgment or conscience. If you don't believe in free will, then how do you see moral decision making? And if you do believe in free will, how do you see moral decision making? Something to think about. Sacrificing short-term interests. Morality, as we would tend to think of it, may often require that people sacrifice short-term interests for the wider benefit of others. Does that mean you have to just completely sacrifice everything for other people? Right? I mean, we wind up with things like the utility monster and other kinds of concepts that are troubling. Moral duties. Are you obligated to act in a certain way? Is there the right action and you're obligated to do that? Kant thinks you probably are. Good object, intent, and circumstances, right? What makes an action morally good can include the object of the action, right? I'm helping a homeless person, or I'm helping a billionaire. The intent, right? I just want to do good for anyone who needs my help. And the circumstances. Okay, I have to have all this information in order to evaluate whether an action is morally good or not. Rational principles, right? Moral requirements are rational principles that tell us what we have an overriding reason to do. And it should be rational. We should be able to say, this is why I'm obligated to do this. This is why it's wrong to do this. I should be able to give you reasons. And motivation, right? A person's motivation can make their action morally good or morally wrong. In a court of law, most cases, you have to consider mens rea. Did I have the criminal intent when I committed the action? If I didn't, perhaps I'm not guilty of a crime. Not all crimes require mens rea, but many of them do. It's a very common principle. So there are 4 primary personal approaches to ethics. The rule-based ethics of Kant. Kant says, act in a way that you would see become an objective, universal law. So you're trying to decide whether you should shoplift. Should everyone just shoplift? Is that a thing we should do? Think about that, evaluate it, and see what you think about that. He also tells you, act so that you treat humanity always as an end and never as a means. What is that about? People aren't objects to fulfill your desires. They're not tools. They are other conscious creatures. They are ends in themselves, not a means for you to achieve your ends. If you're curious about that, I recommend The Theory of Justice by John Rawls, and there's a crash course video for you as well. Contract ethics comes from Hobbes. And he says, right acts are those that do not violate the free, rational agreements that we've made, both explicit and implicit. And there are many of each. If this is intriguing to you, I recommend What We Owe to Each Other by Scanlon. There's a crash course on that as well. Consequentialist ethics comes from Jerry Bentham. An act is good or bad based on its consequences. I have to evaluate your action, right? You tell me why you did it. You give me your reasons. And all of that may seem good to you, but what I care about is what happened as a result. You had the best of intentions, but the road to hell is paved with good intentions. The act was a bad act because it had bad consequences. So the principle here is act to produce the greatest good for the greatest people. And you can read Practical Ethics by Peter Singer. It's a crash course for that as well. And then finally, virtue ethics, right? Aspire to be virtuous. I'm not going to tell you explicitly what's good or bad. I'm going to tell you that you should try to be courageous, you should be temperate, you should be just, you should be wise, you should look and see what other people do who you believe to be virtuous, and you should try to follow and emulate what they do. It comes from Aristotle, and you can read After Virtue by Alistair McIntyre, and there's a crash course on that as well. We have a general agreement from all four of these, believe it or not, and that is that you have some kind of an obligation to each other, right? So up at the top with Kant, you definitely do, right? Treat people as an end and never a means. Contract ethics, we have these implicit and explicit agreements of things that we owe to each other. Consequentialist ethics, act to produce the greatest good for the greatest number. Virtue ethics, same thing, right? Look and see what virtuous people do, people who are considered virtuous, and try to emulate them. And that's usually going to be people who are temperate, just, and wise. And so they're dealing with others honestly and with not with extremes. They're temperate. So we have an obligation to each other. We should act in the manner that benefits ourselves and others, right? You're part of humanity. You can't say, well, I'm excluded because I'm thinking what I should do. No, you're part of humanity too. Or we should act in the manner that benefits the greatest number, or the manner that ultimately has the best outcome, right? We start out and we say we have an obligation to each other, but then we diverge in terms of how we measure whether it's a good act or a bad act based on the different models we just gave. So let's think about ethical standards in computing. The Association for Computing Machinery is a professional organization that many of you probably belong to, and they have a code of ethical conduct. This is true for most organizations. It's true for universities. It's true for employers. The degree to which these different organizations enforce their code is, of course, going to vary. The ACM established a code of ethical conduct for computer scientists back in 1992. Then, in 2018, they decided they'd better update it. And we'll talk about why in just a bit. But their updated code, people really like that. And so, for example, the International Federation of Information Processing, or IFIP, adopted their code to create their own. And it's been seen as a model for many other professional society codes of ethical conduct. So what's in it? What's in the ACM code? Well, it talks about professional responsibilities, professional leadership, and the ethics code. And there's a link to go see the code itself right there. But basically, you can boil it down to some bullets, and you can say, contribute to society. You're a member of society. You have this knowledge about how these fancy machines work. You should use that for the benefit of all humans, well-being of society, of human well-being, etc. So that's what you should do. Avoid harm, right? Don't use what you know to hurt people. Be honest and be trustworthy. If you're not, you'll call the entire profession into disrepute. They'll say, well, those computer science people, they're all sneaky, worthless people. No, be honest and be trustworthy. Be fair. And take action not to discriminate. This is a hard concept, I think, to get your head around. Not discriminating often requires positive action because we have systems that have bias built into them. It's not really any dispute about that. We've had we've had centuries of building up these systems to advantage certain groups, to disadvantage other groups. We've built up our data sets that we use. They have that bias baked into them because that data was collected during a time when all these biases were in force. And they still are, and so we're still collecting bias data. All data has bias baked into it. And so it's not enough to just say, well, the data tells me this, or I'm not going to discriminate. You have to take some kind of positive action to be sure that you're not discriminating. Okay? Respect the work required to produce new ideas, inventions, creative works, and computing artifacts. What does that mean? That means don't steal other people's work and take credit for it. Respect privacy and honor confidentiality. Okay. Honor confidentiality is at the bottom of that list, and it's down there for a reason. Some of the other things in this list might require you to break confidentiality, but if you're breaking confidentiality for the good of human society, then you should do it. There's a collection of case studies available. That link, you can go and read the case studies. It's helpful when you're trying to understand the code to see how it gets applied. The preamble to the code is right here. It says the code is not an algorithm, right? You're all computer science students. Is this another algorithm? No, it's not. It's not an algorithm. It's a basis for ethical decision making. Questions related to these kinds of issues can best be answered by thoughtful consideration of fundamental ethical principles. Understanding that the public good is the paramount consideration. There it is again, right? The one thing we can all agree on is that the public good should be the paramount consideration. The entire computing profession benefits when ethical decision-making is accountable to and transparent to all stakeholders. It makes us all look good, and people will trust us. If we behave in shady, crazy ways, no one's going to trust us. It's going to cause the entire profession to fall into disrepute. All right, so what would I do? So I'm considering an action, and I might ask, why am I considering this action? What's my intent? Do I intend something good, something neutral, something positive for only me, or maybe positive for my family, or maybe positive for my friends? What are the consequences of this action? Right? What's going to happen to me if I do it? Or what could happen to me? Right? Use your imagination. What could happen to me if I do this? What could happen to others if I do this? What might happen in the short run? What about in the long run? Right? Think about the long run. Is the thing I'm about to do legal? That's certainly a concern, right? That has, doing illegal things can have consequences for you. So maybe you shouldn't do them, or you should at least think about this in relation to everything else. Sometimes the ethical thing is not moral. Is this action consistent with the ethical codes I've agreed to? Right? Am I violating the ACM code? Am I violating the IEEE code? Am I breaking the school's policies? Is the action consistent with my own moral code? Will I feel good about doing this? Can I justify to myself why I did this? And can I justify this action to others? So I do this, and then you confront me and say, why did you do it? And I say, I did it because, and give you my reasons. Do I believe I can do that? Would I accept that my actions should form a universal law? Do I believe this is how everyone should behave? That takes us to the ethical crisis in computing. So why did the ACM revise its code in 2018? Now, wasn't the old code good enough? It revised it in response to the perception that there was a crisis in computing. As an example, I point to this article in the Boston Globe, Computer Science Faces an Ethics Crisis. The Cambridge Analytica scandal proves it. Pretty strong words. That article is available online. You can go read it. But it posits that, hey, these computer science people, they don't have any ethics. They're just out there running around, doing whatever the heck they want to do, and they're hurting people, and they're hurting the country, and they don't care, and it's bad. The perceived crisis arose from two major sources. There are others as well. The application of AI decision-making in criminal sentencing and loan approval, policing, and so on. These are instances where an algorithm is fed prior biased data, and then it generates new biased conclusions, which subsequently create new biased data. The bias was baked in at the start, and it doesn't go away by putting it through a computer. The mass collection of data resulting in violations of personal privacy. These are instances where companies may misrepresent or hide their actions. They steal or collect your data. They trade that data with other organizations beyond your control. They may have, for instance, bad data about you. People write bad code. There are vulnerabilities in code. Someone comes along and puts your name in a database, and then they flag you as a registered sex offender, but you're not. How do you fix that? It gets copied and shared. It gets sold to others. You're now in 20 different databases flagged as a registered sex offender. How do you fix that? Okay, there's serious problems here. People have had their credit ruined, other problems through no fault of their own, just because of this kind of devil-may-care attitude toward people's personal data. The perception began to be that computer professionals who were in a position of public trust did not act like it, and they routinely betrayed that public trust. I talked about data having bias baked into it. The algorithms that we build on top of that, they can be biased, right? And if you'd like to know more about that, there's an article in Vox available here where Rebecca Hallowell goes and explains why algorithms can be racist and sexist. Good reading. Privacy. Privacy is a fundamental human right recognized by the UN Declaration of Human Rights, and it was ratified by the U.S. We're always like, well, it didn't apply to the U.S. because we didn't ratify it. We ratified it back in June of 92. So that means it's binding, right? Well, sort of, kind of. In 2004, the Supreme Court of the United States, in the case of Sosa versus Alvarez McCain, decided that the Declaration of Human Rights informs, it's okay to read it, but does not impose obligations under U.S. law. And there's a link to that court case there, and you can see how that plays out. Still, it's the case that a bunch of SCOTUS cases do recognize a right to privacy as a unifying principle from the Bill of Rights. It is also the case that is slowly being eroded, or maybe quickly being eroded. It's hard to say. One of the cases that explicitly said there is a right to privacy arising from the Bill of Rights was Roe versus Wade. That was overturned. And so the question becomes, what about the right to privacy that was expressed in the Supreme Court's original decision in Roe versus Wade? How does that still apply? Are we still doing that? What's going on? In the United States, the government typically is supposed to have a compelling reason to invade your privacy. It could be exigency. Someone is screaming, and so the police bust down the door to find out what's happening. They might have a warrant. They might have a court order. They might have probable cause, right? They saw you run into the house with a gun. They heard shots. It's probable cause. And also exigency. We're going to go do something about that, I hope. So they need a compelling reason, at least for now. Is privacy dead? No. We talked about this before. Companies want to protect their data, and they want to protect their trade secrets, and they want to protect the data they've collected about you and about others. And the data they're collecting and monetizing is valuable because they have it and others don't. If they can't protect that data, then it's not monetizable anymore. These companies will make their data available under license agreements that require a licensee to protect the data, and so that means that it puts an additional privacy burden on the licensee. The data protection measures that they're using for all this are in many ways the same ones that would need to be used for privacy more generally. So yeah, privacy is not dead. Privacy can be equated to money. People like money. There you go. Is individual privacy dead? Is your personal privacy dead? No. There are people around the world who get persecuted because they happen to be born with the wrong ethnicity in the wrong country, or their parents practice the wrong religion, and now they do, or a million other things. And those people need privacy in order to thrive and contribute to the world. There's an argument that you sometimes hear, which is if you've got nothing to hide, you've got nothing to fear. And that sounds, on the surface, pretty reasonable. But it presumes a couple of things. It presumes that the agents, the surveillance agents who were implied by that, nothing to fear from who? From the people who want your information. You have nothing to fear from them because they share your values. Do they? Do they share your values? And if they don't, and they find out what your values actually are, is that a problem? And that they act in good faith. They want your data, but it's fine. We're just doing this or that. Acting in good faith, sharing your values, is that true? Can we count on that being true? And can we count on that always being true? Has it ever been true? So we have to deal with this, right? People do need individual privacy. Right? Protecting the privacy of your users is your moral, right? You have a duty to each other, and ethical. There are actually societal rules and often even laws. Your duty, your moral and ethical duty as someone who creates a software system. If you're going to do this and you're going to collect their data, you have taken on a responsibility, right? With great data comes great responsibility. As a person who's designing, implementing, certifying, and approving software systems, maybe not writing the code, but you're the person who is seeing that the code gets written and you're approving it, it's your responsibility to make sure the systems don't cause harm. You don't get to shirk that off onto somebody else. It's your responsibility. Well, that's it.